Okay, go over the one on the graph that I thought was the V, but it wasn't.
Yes, that was really funny. Can you guys
Number
believe
9.
it?
I got it.
Silly.
I was so sad because I had to redo it, and I was so confused because I didn't know it was a different
All
song.
right, girl. All right, everybody has their notebooks open, mouths closed. Why don't I see anything here? There we go. Just tell me what question you would like to go over, and we'll do it. Emily A, what would you like?
Number 9.
Number 9, we'll get through it and we'll be fine. Yep, that's the face that I was expecting as soon as I looked up. All right.
It's like this when Tana watches Coconut.
Yes, it's kind of like that, like graphy. All right. Are we saying ew to this graph? We're open markers there. All right, guys. Number 9 asks for the domain and the range of this function. What type of function is it?
Negative.
That's a positive. It has a positive slope.
It's
Positive, negative, graph, math, algebra. What kind of a function is it? I'll give you a hint. We've learned about, yeah. Yeah, that's true. You took the words right out of your mouth. Were you going to say linear? You're like, no. Okay. Well, it is a linear function. That just simply means it's a function that forms a line, as opposed to the other functions we've been working with recently that form the V shape, which we call absolute value functions. So I just want to identify that this is a line. Not only is it a line on the graph, but it has arrows on both ends of the line, which means the points on the graph continue. This line is really, it looks like a line, but what it is it's every tiny little point on the graph and they connect together because they're so close to each other, because they're so tiny that it forms a line. So it's every coordinate pair joining together to make a line. Even coordinate pairs like 0.1234567845321, like that, and then with a y value of like 0.98723, like 8675309, like that kind of stuff. Anybody? That's like an 80s song. 8675309. Never mind. So every coordinate point, even the most ridiculous decimals for x and y, the ridiculous mixed numbers, those are all points on this line because it's all this line is all connected by points. It's like I connect the dot and it makes a straight line. Since it continues in both directions, would you say that it's continuing upwards or is it continuing to the right? What do you think?
I mean, it's going up, but it's not turning.
It's not turning. So are you saying this is only going up, or is it also continuing to the right?
It's continuing to the right.
It's going both ways. It's going like kind of like northeast, right? It's going, if we were to call these cardinal directions, which this isn't a map, so we don't really use north, south, east, and west. But if we were, we would say it's going north and it's going east, right? So it's going 2 directions at once, which is causing it to have that diagonal line. It is going north, right, on the y-axis. As it continues, the y-axis values are continuing. As the x-axis stretches out and this line goes, even though it's going up, it's still kind of matching x values as x continues to positive infinity. And if we look at this side, all of these points have x values over here also. They're just not on the x-axis except for this guy because they also have y values. But as this line continues down, 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 it's also continuing left, left, left. Since the question first asks for the domain, we're going to answer what type of values?
Domain is a real number?
Well, yeah, true. I was asking, like, is it the x or the y? Yeah, we're looking for the x values. It also has y values, but for now, when we describe the domain, we are describing x values. And Ricky is correct. Since the line continues forever towards the right and forever towards the left and 0 and everything in between, we would simply say that x is a real number, which means x is literally every single number that you could ever think of and more. Does that make sense? So out of all of those answer choices, because there are a lot of them, the answer should be x is a real number when you see a continuous line like that, a linear function like that. Now let's talk about our y values. And Ricky, I know you know the answer, so I'm actually not going to call on you this time because I want to kind of pick on somebody who might have a little trouble. And if you have a little trouble answering this, that's good, because that means I can help you. Because what's the point of me just asking questions and you guys get all the right answers? That would be so boring. And math shouldn't be boring, it should be fun. So we do know that the domain is, x is a real number. Now, Angeli, help me figure out what we would say for the range of this function.
The same thing.
Very
It's the
good.
same line.
It's the same line. It's also, as it's going to the right, it's also going up all the y values. It's also going down all the y values. Even though it looks like it's getting further away from the y-axis, it doesn't matter how far it gets from the y-axis. As long as it's still traveling down, it matches up with the y values. So you're right. This linear function continues in both directions, so x is a real number and y is a real number. So just like she said, it's the same answer. Y is a real number. Of course, same answer, but of course, making the distinction between x for the domain and then y for the range. Does that make sense? Did I hit record?
Yeah.
Okay, good. Next question.
50.
You got it, dude. You'll notice that some of these questions on the end might look like, huh? We didn't learn this. Yeah, you did. It was like lesson 1. I pulled some questions from the homework of lesson 1. Ricky, does yours look like this or does it look different? I can give you, you can tell me what yours is. Now, the reason I told these is not to trick you, it's to give you some easier questions that don't require too much thought. It's just a little bit of combining like terms and solving for x.
Lesson 1.
Yeah, but I took the easiest questions from lesson 1, not those crazy questions. I do, I remember doing lesson 1 for a month. Yeah. This is number 15. Ricky, give me your example because since I pulled from the homework on the last couple of questions in this practice test, it's going to generate different numbers. When I just pull from the practice test, it keeps everything the same for everybody.
It's the same.
What? Yeah, it probably has like 3 or 4 problems for this question, and it just like spits out whatever. So you'll match me sometimes, Ricky will match mine sometimes. Go ahead and tell me what yours was, Ricky. 5x plus 4 minus 3x. The way that I solve this is exactly how I want you guys to solve it. Can, just by a show of hands, and this is just helping me, it's not telling me if you, whatever. Tell me if you got number 15 or any of the questions like this. Tell me if you got any of them wrong or had trouble on them.
No,
Okay.
I didn't know what to do except I got 16 wrong. That's why I wanted to go over.
Okay, we can go over that one too. But let's see if we solve this, if you could maybe do 16 on your own, okay? So when I have a problem like this, and again, this is going back to the very beginning of the year, but this is also technically review from last year. So I'm trying to give you something really simple without bogging you down with all these like crazy domain and range questions, okay? So we have to solve for x. It says solve the equation, meaning solve for the variable and find out what x equals. We have x in 2 places. Over there we have a 7x and a negative 3x. Over here I have a 5x and a negative 3x. I'm going to combine those like terms. Because we can solve for x as long as x is only in one spot. Then we'll be able to solve for it. So if I combine a 5x and a negative 3x, Ricky, what do I get? 2x, good. So I'll just write my 2x here, and then I'm gonna cross it out. And if I'm doing that, you are doing that, okay? Not just right now, which you should be doing right now, but also on the test. You should be using scratch paper and doing it like this.
What number is this?
Number 15. So then I have my positive 4 that can't be combined with anything on this side, so I just put it right down here. And all I did is take 3 terms and condense them down to 2 terms by combining my x terms. We're allowed to do that. X is kind of like saying if I have 5 apples and -3 apples, I put that together and I get 2 apples. You could also say if I have 5 apples and I give away 3 apples, I have 2 apples. Your variable just stands for a very certain thing that is the same wherever that term is. So and then my positive 4 cannot be combined, so I'm just going to bring down my 20 equals, so I'm rewriting this equation in a simpler form. And then the last thing I need to do is solve for, solve for, good,
You subtract 4.
Good. Cancel, cancel. What do I do?
Divide 2 over 6.
Divide by 2. Both sides, and I get x equals 8. What can we do if we have a little extra time on our test? Check your answer. Plug it back in. 20 equals 5 times 8 plus 4 minus 3 times 8. And just double check that this is correct. Remember your PEMDAS multiplication comes first before that addition and subtraction. So we get 40. And then a -3 times an 8 is?
You're on your own.
Huh?
You're on your own.
I'm on my own. -24. Why? Because you don't have a calculator.
Yeah.
And then I have a +4. So now I'm going to solve from left to right. And I have 40 plus 4 is 44 minus 24. And what do I get?
20.
20. Did the 8 value work for x? Absolutely, it did. So now we know that 8 is our answer for this one. Does anybody need me to go over this one, or you guys totally have it? Honestly, I think checking it is a little trickier than solving it. Checking it kind of is in place for silly mistakes because of all this negative and positive and order operations. Okay, yeah.
14 and 13.
So graphing this equation,
It's triple.
it's difficult? Okay. So I'm just gonna sit down here for a second, okay? So we can see over here. Can I move this? Is that possible? Or they just, no, they don't do that. Okay, so we have up here, we have y equals -4x plus 5. This is another one from a previous lesson that I'm trying to give you to make it easy. What are the steps to graphing a linear equation? What are the steps? What is the very first thing you do?
You don't make it.
You don't make the v because this is a linear equation. A v, an absolute value equation, has an absolute value symbol. If the equation doesn't have an absolute value symbol,
So it's like the
it's
two
not a
lines.
v. What?
It's the 2 lines.
2 lines?
No, so
You mean 2?
like that, kind of. So if there's not that.
Oh, are you saying that what does the absolute value symbol look like? Yes. Pretend my head is a number or a variable. That's absolute value. Okay? It's like a little absolute value jail. So, since we know that this is a linear equation and not an absolute value equation, what do we do first? Is that what you were going to say?
No.
What were you, it's okay, what were you going to say?
Well, I don't know why it's just really weird because like 13, I didn't really know what to do, but like
No, but like for this
I know,
one,
yeah, but like this one, the two do you put the negative 2?
Oh, do you have a different, okay. Tell me what you have.
Y equals negative 2x plus 4.
Okay, so this is the one we're gonna graph, so that's not too confusing for you. All right, so, just gonna get my line for our linear equation. And now I have a negative 2x plus 4. In order to make a line, I simply need to graph 2 points. Based on this slope-intercept form, what should I graph first, Emily?
Negative 2.
Where should I graph the negative 2? On the x? Okay, so you're saying that,
No, I don't know.
do you remember what Angeli said just a minute ago? Well, what did she say to graph? You didn't say a number, you said the specific. Yeah. The y what? Yes. What's the y-intercept in slope intercept form? Slope intercept form. The y-intercept is good. So okay, so I see a 4 here and a 4 here. Where should I graph that point? On the y, because it's the y-intercept. That's point 1. How do I figure out where to put my second and final point?
Is this where you put the negative 2 or?
What do you mean, put it? Like,
If you, because like you would go down to the right one.
that's correct. This is the slope. Negative 2 is the slope. That's why we call it slope intercept form. Slope is rise over run. So this negative 2, you're right to say that it's over positive 1. Because if you have a whole number, then your slope, your rise over run is negative 2 over 1. So what I'm going to do is I'm going to go down, I'm going to start at this point, and I'm going to go down 2 units. 1, 2, and then do I go to the right or to the left one?
Right.
To the right, good, because we took care of the negative with the 2 going down, and then we just go to the right one, and that's it. And that's your line. And then you just press enter and you're done.
Thank you.
Does anybody want to try to graph this one that I have over here? Sure. Let me just clear this. Yes. Yes. Okay, Emily, what should I graph first? Good. We're going to put a positive 5 on the y-axis.
Wait, what question is this one?
This is 15, I think?
No, we're on
14. Okay. So I graphed that, and now the graph is like, hey, where do you want your other point? I can make any line you want. Step right up, step right up. How do I know where to put my next point? Down 4. 1, 2, 3, 4, and then to the right one. That's it. So that's graphing a linear.
And then 13, it gives you like a fraction. So like you just still do like the same thing.
Yeah, it's the rise over run.
Go down, go up 7, and then right 9.
Yeah, mine says down 2 and then to the right 5. If yours is a positive 7 over 9, you would go up 7 and to the right 9. Up and to the right.
And then can you do 16?
16? Sure. Hope you guys are taking notes.
This for number 13.
Okay, so
Do you want mine?
yes, but I really want you to walk me through it because we just did one just like this. Okay, go ahead and give me yours.
I might have like done a math on, but like it's 9 minus 2x minus 7 minus 13x equals 5.
Does that look right? 9 minus 2x minus 7 minus 13x equal 5? Equals 5? All right, I'm going to just take one of my favorite colors so you guys can see it better. What's the first step?
You combine all the terms.
Combine Combine like terms. So before I combine like terms, I'm going to circle each term with its sign. That's going to be my first step. If you were reading a textbook, it would probably say combine like terms as your first step, but I like to separate my terms with their signs, so when I combine them, I don't have to figure out what sign goes to what. Especially when you have something like no sign, you know that it's positive, right? Okay, so which ones can I combine?
You can combine the negative 13
Okay,
and the negative 2.
good. So the negative 13x and the negative 2, and you get what?
Negative 15.
Negative 15x. Cancel, cancel. What else?
And then you get 2.
And then you get 2. You combine your 9 and a negative 7, and you get positive 2 equals 5.
So then you subtract 2 on both sides.
Uh-huh.
And then you get 3. So it would be negative 15x equals 3.
Correct.
And then you divide negative 15 on both sides.
Just divide by negative 15 on both sides. Negatives 15s cancel out because it's being divided by itself.
So that would be negative 5. X equals negative 5.
Wait. What?
Yeah. X equals negative 5.
Really? X equals, how does x equal negative 5?
If I put it in 3 divided by negative 15, I get 0.2, but then when I do negative 15 divided.
So are you gonna base your answer on which one gives you a nicer number? That's not how math works. You have to do exactly what it's saying to do. The numerator is smaller than the denominator. You can call this a division problem if you want to. This is the dividend. 3 divided by negative 15.
So I type in 3 first and then divide?
Sure.
Yeah, it gives you the negative 0.2.
Okay. And it says type an integer or a simplified fraction.
Okay.
What did you get? What did you get in the calculator?
Negative 0.2.
Negative 0.2. This is a correct value. If you put it in here, it doesn't follow these rules, so it will mark you wrong. Even though dividing 3 by negative 15 will give you a negative 0.2. An integer means basically a whole number including negative numbers, so all negative numbers and positive numbers that aren't decimals or fractions, and also 0. This is a negative decimal number, so it's not an integer. So we can't type an integer, but we can type a simplified fraction. How can we simplify the fraction 3 over negative 15? Simplifying a fraction means reduce the fraction. Do you remember how to reduce a fraction?
1 over 5?
That's correct, but remember that it's negative.
Yeah, I put negative and then the 1 over 5 and it said it was wrong.
You put negative 1 over 5 and it said it was wrong? So when you see the little red corner there, that's showing you the correct answer.
Oh.
If you click on it, it will show you the answer that you put.
Oh, I just put in negative 5.
Okay, that's because you looked at this and said, you know, it'd be really fun just to divide 15 by 3. You're like, I don't like that it's written like that, so I'm gonna switch it. You can't just switch things to make things a whole number. If it's a fraction, it's a fraction. And it kind of gives you a hint here. It's like, psst, psst, could be a fraction, right? All right. So, your process for doing all of that hard work was totally correct. Then you got to the end. And you were like, I don't want to do that. That's weird. I'll just flip it. You can't flip it. No flippies. Okay, next question. 17? Is it one that's just like this?
Yes.
My goodness gracious, people.
That one I got right.
Ricky, you tried it and you didn't get the right answer? What answer did you get? Have you tried it yet? I can't.
No, because I looked at this one and I didn't understand it at all.
Well, we just did about 3 questions just like it. Can you try it now? See if you get the right answer. Other questions? Sure.
It's like looking at all the graphs is just so big. I mean, I know
Yeah,
I got
anyway.
it right. It's just like because I helped Callie with it.
Yep. 3 and 4 and 5. Just kidding.
Yeah.
Uh-oh. We have less than 10 minutes and my thing is not doing what I want it to do. There we go. Okay, so it says, which graph shows the function h of x equals 3 times the absolute value of x? Well, first of all, which one can you automatically eliminate? Because of what?
A.
Good, because A is showing that it has a negative output. There's no way to get a negative output. If you're absolute valuing the input, it's going to be positive. If you're multiplying by positive, it's going to be positive. There's no way to get a negative. So A could not be correct, and I think the rest of them all are positive, so it could be B, C, or D. Let's see what happens. Well, how did you try to solve this?
So, you helped me with it, but like, what I did was just, I knew it wasn't D because it didn't like go.
Well, let's not use that strategy if you get to your test and you don't remember anything I said. But let's pretend that this is the test and you want to use this function. What?
Has to like cross the 3.
No, that's not what this is. The absolute value of x is being multiplied times 3. So it's basically gonna change how open or like how narrow or wide your V is. But what can we make to find coordinate points that will fall on this graph? No.
0? What?
Can anybody else help? What can we do?
Question?
How do we figure out what coordinate points could be a part of?
3.
No, any.
Yeah, we can make a table, right? We can make a function table where we put in a value and we see what gets put out. That's why it's called input and output, which is also our x and our y for the coordinate pair. We put in a value, any value we want. I highly recommend using -1, 0, and +1. There will be some functions where you're like, that's just forming a line, let me keep going, and then it'll eventually go back up. But for this one, all we need is these 3. Now, I like to write my entire function, because the output, I have to plug in my -1. So, to what? 3 times the absolute value of x, that's my original function. Now we're just going to plug things in. 3 times the absolute value of -1. Absolute value of -1 is what? +1. +1 times 3 is 3. So that's the first coordinate pair. Let's go ahead and take a look. We know it's not A. I'm just going to do 1 and see if I can find it. Yeah.
Can I go with water?
Yeah. Can you walk around?
Yeah.
All right, let's look at B. -1, +3. -1, +2. Guess what? B is not the answer. Let's look at C. -1, +3.
Yes.
That is correct. Let's check D. -1, +3, no. Just even doing 1 simple input and output into this function actually allowed us to narrow it down. Now, if we had to draw our own with the little V tool, the absolute value tool, we would have to get more coordinate
Is that
pairs.
going to be on the test, like we have to draw it?
It should be just like this.
So we don't have to draw it?
Not for this question, but if you had to draw it for a different question, then you will. And you need to be able to. How do you do it? Keep plugging in. Plug in your input 0. 0 absolute valued would be
0.
times 3 is
0.
0, which I'll show you back on C, that 0, 0 is also in here. So we have 1, 3, 0, 0, which by the way is also on the other choices. And then 1, if you plug that in, absolute value of 1, 1 times 3 is 3. Notice how here is where you're going to start seeing the symmetry, because our outputs for both the negative one and the positive one are 3. So negative 1, 3, positive 1, 3. That's where you see that symmetry in that absolute value function. Okay? And did you say number 2 also?
Yeah.
I'm going to show you the number 2 way. What I think is the quicker way. You can do this by making a table. Nobody's packing up. You can do this by making a table and just plugging in values and then finding your x-intercept, and that's in my notes. Also in my notes I say there's another way. Nobody's packing up. Okay. The other way to solve this is, we know that an x, to get an x-intercept, the y value has to be, what does the y value have to be?
0.
Yes, the y value has to be 0. Where's my y value here? Do you see a y value? No. That's
Oh.
what we would call a y intercept. What?
There's no y value.
There is a y value. It's in disguise.
X?
No, x is x.
0. 2.
My y, my output,
The F.
f of x. This is my output value. This is my y value. The output, my y value would be 0. My input would be x. And then this is the function. To solve for x, solve it just like a regular equation. Watch this. Cancel, plus 2, and I have 2 equals the absolute value of x. Now, tell me the number, or numbers. Why are you guys backing up? I'll let you go in a second. I've got a minute, but the zipping makes everybody think it's time to go, and it's not. So x, which is a number, when it's absolute valued, it'll give you positive 2. What is that number?
2.
2. And
0. F of x.
what is the other value that when it gets absolute valued, it'll get you positive 2? Negative 2. 2 and, I'm not gonna write it, 2 and negative 2 would be your x values. When you choose it, hold on, when you choose it, you have to choose, look, oh gosh, that's really tiny. It says 0, 0, 0, negative 2, negative 2, 0, and 2, 2. Yeah, you can get it. Now, 2 could be an x value. Oh, that's y value. And negative 2 could be an x value. So are these both correct? No.
Oh, wait, no, because the 2 and 2, and 1 is not negative. They're both positive.
Can I go?
That's not why it's wrong. Yeah, you can go. What is the y value to get these numbers? 0. The y value was 0. So if the y value is 0 and the x value is negative 2, this is your x-intercept. This would be positive 2, positive 2. How is that an x-intercept? It's not even on an axis, right? So even though both of these are your x-intercepts, what it's saying is it's at positive 2 on the x-axis and negative 2 on the x-axis. That's the symmetry, okay? That's the symmetry of this function. If you were to graph it, it would look like this. Does that make sense? This is what I think is like a quicker way to get it, but it might be more complicated. I'll explain in regular class the other way to get it, because I know that's a little complicated. Angela, can you press stop on that?